Hey, junior scientists! Welcome back to Learn with Mike, where science is made fun and easy. Today we're jumping into something super important, matter and its properties. So, what is matter? Matter is anything that takes up space and has mass. That means if you can touch it, see it, smell it, taste it, or hear it. It's matter. Just like the water in this kettle, the kettle itself, everything around it, and even us. Matter is made of tiny building blocks called atoms. Fun fact, the word atom comes from a Greek word meaning cannot be divided. Cool, right? Let's zoom in to look at an atom. Atoms are like little solar systems with 3 smaller particles. Protons are positively charged particles. Neutrons have no charge at all. They're neutral. Electrons, on the other hand, are negatively charged and super tiny, with almost no mass. The center of the atom is called the nucleus, like the yolk in an egg. It's packed with protons and neutrons. Electrons, on the other hand, zoom around the nucleus so fast it's like trying to catch a buzzing fly. You can't really pin down their exact spot. When we talk about physical properties, we're talking about how something looks or feels without changing what it actually is. Examples: color size and shape density, which is just how heavy matter feels for its size. Malleability, which is just a fancy word for how easily an object can bend or flatten. Magnetism, boiling and melting points. Solubility, which is how well it dissolves. Physical changes happen when these properties change, but the substance stays the same. Example: nail polish. It starts as a liquid, dries into a solid, but it's still nail polish. Now, chemical properties are different. They describe how something can change into an entirely new substance. Examples include flammability, which is how easily something burns, and reactivity, which means how something reacts with water, oxygen, or light. Chemical changes create a new substance with new properties. Example: a log burning into ash. Now it's something totally different. Next question to ask yourself is, how do we know if a chemical change has happened? Here are the clues. Change in color, like a potato turning black when sliced. Energy released in form of light or heat, like fireworks. New smell, like rotting food. Gas or bubbles forming. Example in a vinegar plus baking soda experiment. And remember, chemical changes are usually hard to reverse. You can't turn burnt toast back into bread. Even after a change, physical or chemical, the mass stays the same. Why? Because atoms don't disappear, they just rearrange themselves. In a physical change like butter melting, it's still butter, just not solid anymore. The atoms aren't packed as tightly, they're moving around more freely. But it's still the same butter. In a chemical change like wood burning, it turns into ash, smoke, and gases. But if you could collect all of it, the total mass would be the same as the wood you started with. This important rule is called the conservation of mass. So mass is never lost, it just changes form. In a reaction, we use 2 important words. Reactants, the starting substances and products, the new substances formed. And because of conservation of mass, the mass of the reactants equals the mass of the products. Science is balanced. And that's a wrap for today, junior scientists. We learned matter is made of atoms, physical versus chemical properties, physical versus chemical changes, the law of conservation of mass. Next time, we'll explore the states of matter, solid, liquid, and gas. You don't want to miss it. Thanks for watching Learn with Mike. Don't forget to like, subscribe, and hit that bell icon for more science adventures. And remember, always stay curious.